This video will focus on naming type 2 ionic compounds. Remember, type 2 has more than one oxidation state. An ionic bond is simply just a metal and a nonmetal bonded together in a mutual force of attraction. I'll be using a couple of terms. I'll be using the cation, which means that it is a positive charge, and I'll be using an anion, which means that it's a negative charge. When I run into these type 2 ionic compounds, I'm looking for mostly the ones that are the transition metals. Those are the ones that are here, that are highlighted in blue. They have more than one oxidation state. So some transition metals do have only one oxidation state, and that's why this reference sheet is great to keep in mind which oxidation state is available. So when we run into these, we'll notice we'll have to ask ourselves this question: which oxidation state do I use? And you're gonna have to follow some context clues based on what nonmetal it is paired with. So let's do some examples where we're going to use our context clues to find our oxidation states. I want to write the formula for the compounds formed by these ions. So if I notice that all of these anions are all transition metals, and they all are part of the blue squares here. They have two different oxidation states, but all of the anions here are all negative charges, but they do not have any double oxidation states. They can only be one. So when I pair these together, there can only be one type of possibility. When I pair them together, all I have to do is just follow the normal crisscross rule. The crisscross rule was so the 2 plus came down here to be a subscript of 2, and then the 1 minus came down here to be a subscript of 1. So that's how I got that answer. Here the crisscross rule will still apply, but now many students will write Fe2O2 and be done with it. That is not the best way to go, because you can still divide by the least common denominator. So I would need to write FeO because the 2 plus and the 2 minus will cancel out. We'll still follow the crisscross rule for the rest of them. Since I followed the crisscross rule for this last one, iron and oxygen, the 2 came down here to be a subscript, and the 3 came down here to be a subscript. So that's where the 3 comes down to the oxygen, and the 2 comes down to the iron. This is Fe2O3, or iron oxide, very common element. Now that we're comfortable with the crisscross rule in writing chemical formulas, now let's write the chemical names. So these chemical names for the type 2 ionic compounds are always going to have a Roman numeral in them. And I'll give you an example. We have copper, 2 plus, and a bromide. So that is going to be copper copper 2 bromide. Here we have iron and 2 plus and then an oxygen. So that's going to be iron 2 oxide. I'll fill in the rest of them, but until we get down to here. Alright, iron 3 plus, oxygen 2 minus. So this will be iron 3 oxide. Now it's just a coincidence that these are all, most of these are Roman numeral of 2. That doesn't always happen that way. It's just the way the examples worked out. These are because that each one of these transition metals can have several different oxidation states. So we have to distinguish between which oxidation state it is. That's how we are able to distinguish in word form. Uh, and just to reiterate that the Roman numeral 2 does not mean that there are two coppers. It just means that there is a 2 plus oxidation state.